Apart from the Sun, the Moon is the most prominent feature in our sky. But why do we have a moon? Where did it come from? Before the moon landings, many presumed that the moon would be made of the same rocks as the Earth, because Earth and Moon had formed as a pair, as part of a single eddy in the swirling cloud from which the solar system condensed. Other scientists predicted that the moon rocks would be totally different, because the moon was a passing planet that had got captured in the Earth's gravitational field. In fact, moon rock turns out to be similar to the rocks deep in Earth's interior, so a different explanation is required. A plausible theory is that a Mars-sized planet hit the Earth and merged with it. Molten material from the interior was ejected by the collision. This condensed to form the moon.
In the middle years of the 20th century, a race to the moon between Russia and America took place as both nations tried to prove they were technologically superior. The benefits to science were enormous. The American astronauts touched down on the moon in the lunar module of the Apollo 11 mission in 1969. A further 6 missions to the moon, including the unsuccessful Apollo 13, ended with Apollo 17 in 1972. In all, 12 astronauts have got to walk or drive around on the moon, collecting invaluable evidence for the history of our world. By exploring on the surface of the moon, the astronauts made many unexpected finds. Firstly, they discovered that the moon is made from rocks similar to those deep in the Earth's mantle. Secondly, that it is volcanically dead. The many enormous calderas, thought by some to be volcanic, were all formed by meteorite impacts. Thirdly, lunar seas, large flat plains of lava, were formed during the era of late bombardment. This was a short period of intense meteorite bombardment, about 3.9 billion years ago. In 2005, Europe, the United States, and other countries began discussing plans for a manned mission to Mars, the first step of which is to establish a permanent base on the moon. That base is likely to be situated near the south pole of the moon in Shackleton Crater, named after the great Irish explorer Ernest Shackleton, who pioneered exploration of the South Pole here on Earth. Parts of Shackleton Crater are forever in shadow, and many experts think there could be water ice from comets hidden there. Water could be used to supply a lunar colony with air and rocket fuel, as well as all the water they needed.
Exploration of the moon revealed evidence for what we now call the era of late meteor bombardment. This was a 100 million year long period, 3.9 billion years ago, when conditions on both the Earth and the moon were very similar, a molten hell. The solar system formed in violent collisions of debris 5 billion years ago. 1 billion years later, a second intensive bombardment began. Perhaps it was caused by a star passing by, or maybe by the breakup of another planet. There is no erosion on the moon, so we can clearly see the craters and lava seas on the moon's surface caused by the impact of rocks up to 10 kilometers wide. The Earth would have been equally intensely bombarded at the same time. The heat would have driven off any atmosphere or oceans to create what is known as the Hadean Earth. As the bombardment eased and Earth cooled, icy comets may have brought water back for new oceans to form on Earth. Weather and ocean and crustal movement have eroded away and hidden all evidence of the era of late bombardment on Earth.
The era of intense bombardment happened around the time that life first emerged on Earth. So did early microorganisms survive the blazing heat at the bottom of boiling oceans, or by burrowing down into the rock to re-emerge later? Or did life only start after it was all over? Was it the meteorites themselves that brought life to Earth from space? There is evidence that they brought organic compounds. These could have been important for the early development of life on Earth. Asteroids and meteorites continue to hit the Earth. This is the 1,200 metre wide meteor crater in Arizona. It is 4,000 years old. This is a radar image of the 17-kilometre wide Arunga crater. It is buried under sand in Chad. It is 800,000 years old. Several changes in climate and mass extinctions of plants and animals have been caused by major impacts since the era of bombardment. No craters survive the era of bombardment, but many giant craters, such as the 300-kilometre wide, 65-million-year-old Chicxulub crater in the Yucatan, lie camouflaged by the Earth's oceans and constantly eroding landscapes, and are only visible thanks to sophisticated radar imaging techniques. Unlike the Earth, the Moon has no atmosphere or oceans to erode evidence for the late bombardment. There are two reasons why. Firstly, the Earth was formed from a dust cloud rich in the elements required to make atmospheric gases and water, such as hydrogen, oxygen, carbon and nitrogen. The Moon, by contrast, was formed from rock and metals only. These were likely blasted from the Earth's deep mantle by an impact with another planet. Secondly, even if the Moon had contained the necessary chemical elements to form an atmosphere and oceans, its low gravity means that they would have probably seeped away into space. The small amount of water buried near the Moon's poles probably arrived with the comets that followed the late bombardment.
This is the aurora borealis, also called the Northern Lights. The sun spews out millions of particles a second, which would kill all on Earth but for our magnetic field. The glowing curtains of light are caused when the particles collide with atoms in the Earth's atmosphere. Most of this solar wind is harmlessly deflected away by the Earth's magnetic field, or absorbed by the Earth's atmosphere. But a small fraction is guided down along the lines of Earth's magnetic field near the poles. This explains why the aurora borealis is most easily seen in countries near the North Pole. The magnetic field forms a shock front that deflects the streams of charged electrons that stream off the sun's surface in the solar wind. It also filters the cosmic rays that come from deep space. So what causes the Earth's magnetic field? Earth's inner core is solid iron. This is surrounded by an outer core of liquid iron and nickel. The heat from the core causes the iron and nickel to circulate, much like boiling water in a kettle, and the circulation of the iron and nickel generates the Earth's magnetic field. The magnetic North Pole is not exactly fixed, and even now, turbulence in the liquid inner core is causing it to move direction and the field to weaken. This probably heralds another flip-flop when the magnetic poles will reverse and all compasses will point south. This is known to happen every 200,000 years or so.
Scientists have discovered that at the present rate, Earth's magnetic field could be gone within a few centuries. Could we someday become defenceless against the lethal effects of solar wind and cosmic rays? Some experts think the field may begin to strengthen again, or it could weaken to the point that it suddenly flips polarity. That is, compasses would begin to point towards the South Pole. But there is no uncontested evidence of previous reversals having caused major problems for life on Earth. Space weather generally varies with the 11-year sunspot cycle. The more sunspots, the more storms and the more voluminous the solar wind, the stream of charged particles that cause the aurora borealis. Solar flares also hurl out protons, electrons and blasts of X-rays. The sun can also spawn coronal mass ejections, billion-ton clouds of plasma travelling at more than 1 million miles per hour that arrive at the Earth in only a few days. Solar storms can disrupt shortwave communication, can cause power blackouts, satellite failures and even pipeline explosions. The Earth is constantly bombarded by cosmic rays, energetic particles that approach the Earth from all directions. The term ray is a misnomer, as the particles arrive individually, not in the form of a ray or beam. 90% of all the incoming particles are protons, about 9% are helium nuclei, and about 1% are electrons. Cosmic rays originate from a wide variety of sources, ranging from energetic processes on the Sun, all the way to supernova black holes and quasars in the farthest reaches of the visible universe.
These are black smokers, the volcanic vents that allow bizarre life forms to live at the bottom of the deepest ocean trenches. All over the world, volcanoes and underwater vents spew gases and chemical nutrients essential for life into the atmosphere and oceans. The Earth appears solid beneath our feet, but the surface is like a giant jigsaw puzzle, with continents moving around and colliding as they float on a layer of semi-molten rock. Convection currents cause the thick plates of crust that form continents to move around over the much thinner crust that lies under the oceans. When a thick continental plate rides over the thin ocean crust, it is forced downwards into the hot interior. The plate melts into lava. This finds its way back to the surface to form volcanoes. Volcanoes spew carbon dioxide and nitrogen gas, both vital for life, into the Earth's atmosphere. Similarly, when convection currents cause the crust to split on the ocean bed, lava moves up to fill the gap. Undersea vents form, filling the sea with chemical nutrients.
Volcanic vents spew out carbon dioxide that has been bottled up in molten rocks deep beneath the Earth. As a result, the planet's early atmosphere was probably almost entirely carbon dioxide. Living things are made almost entirely from carbon and water. Over billions of years, carbon dioxide breathing plants and microbes have extracted the carbon to build themselves. The oxygen waste that they breathe out has created the oxygen-rich atmosphere that air-breathing animals, such as ourselves, need to live. Carbon dioxide emitted by volcanic vents is one of the most important greenhouse gases. You will have heard a lot about how these gases are affecting our climate, but they are essential to the Earth's natural temperature control system. About 1/3 of the sun's radiation that hits the Earth is reflected back to space. The atmosphere absorbs some of what's left, but the land and the oceans absorb most of it. The Earth's surface becomes warm and the greenhouse gases trap the heat. Without this greenhouse effect, the Earth would freeze over and everything would die. The problem today is that human activity is causing greenhouse gas levels in the atmosphere to increase, and the planet is becoming much too warm. This is Old Faithful Geyser in Yellowstone National Park. It erupts several times a day, spouting a column of water heated by volcanic rock deep within the Earth's crust. A hydrothermal vent is a geyser on the sea floor. It continuously spews super-hot, mineral-rich water that helps support a diverse community of organisms. Although most of the deep sea is sparsely populated, vent sites teem with a fascinating array of life. The first hydrothermal vent was not discovered until 1977, and most are found more than 2 kilometres down in areas where the seafloor is spreading, along the mid-ocean ridge system, the underwater mountain chain that circles the globe.